Imagine limitless clean energy. No carbon emissions. No risk of meltdown. Enough fuel to power civilization for millions of years, drawn safely from seawater. That's the dream of fusion power, recreating the reaction that lights up the stars. But after decades of promises, are we finally close to making it real? Fusion is the process that powers the sun. Deep in its core, immense pressure and heat force hydrogen atoms to fuse. This creates helium and releases colossal amounts of energy. On Earth, we already split atoms, fission, which powers today's nuclear plants. Fusion is the opposite. Instead of splitting uranium, we combine light elements like hydrogen isotopes. Done right, it produces far more energy, no long-lived radioactive waste, and no chain reaction risk. The challenge is recreating the sun's conditions. We need plasma hotter than 100 million degrees, held long enough for fusion to happen. For over 70 years, scientists have been chasing that goal. Progress has been slow, but the last few years have seen genuine breakthroughs. In France, the ITER project is building the world's largest experimental reactor. Its goal is to prove fusion can generate more energy than it consumes. In the United States, the National Ignition Facility achieved ignition using powerful lasers. They produced more energy from a fusion reaction than the fuel absorbed. It's not yet practical power, but it's a milestone pursued for decades. And then there's the private sector. Startups like Commonwealth Fusion Systems, Helion, and Tokamak Energy are racing ahead. They promise working fusion plants by the 2030s. Billions of dollars are flowing from investors who believe fusion could leap from lab to grid sooner than expected. But let's be clear, we're not there yet. Engineering a star on Earth isn't simple. Reactors must contain superheated plasma without it touching the walls. They use powerful magnetic fields to hold it in place. Materials must survive extremes of heat and radiation. Experiments that succeed for a fraction of a second must run continuously and affordably. Then there's the timeline problem. For decades, fusion has been called 30 years away. In the 1970s, scientists predicted fusion power by 2000. In the 1990s, they said 2030. Every breakthrough uncovers new technical hurdles. So what's realistic? Most experts believe commercial fusion plants might appear in the 2030s or 2040s. That's not tomorrow, but it's no longer a distant dream. If achieved, the implications are staggering. Virtually limitless clean energy. Reduced dependence on fossil fuels. Powering advanced technologies like green hydrogen and desalination without heating the planet. Fusion won't solve climate change in the next decade. We'll still need renewables for that. But in the longer term, fusion could transform human civilization. So are we finally close? The answer is closer than ever, but not quite there. Fusion is no longer science fiction, but science in progress. The next decade will tell us whether today's breakthroughs can become tomorrow's power plants. And if they can, the energy that powers the stars could one day power our world. If you enjoyed exploring the future, subscribe to Tomorrow Today for new videos every week.